Hey everybody, this is Chapter 4, Section 2. Title is Patterns and Linear Functions. Starts on page 240. Start with a few definitions here. In a relationship between two variables, you've got two variables, the dependent and the independent. The dependent variable changes in response to the independent variable. So it's kind of like a cause and effect thing. So one thing causes something else to happen. The independent variable causes the dependent variable to change. The independent variable is sometimes the thing that you control. Let me give you an example for a second. A lot of times the government calls children dependents of their parents. Okay, children depend on their parents for food and clothes and having a house and stuff like that. So the children depend on the parents. So let's say, for example, the parents have to move. Okay, the child would have to follow. Okay, the independent parent causes the dependent child to have to move. So that's one way that you can think of dependent and independent. Dependent depends on the other thing changing. Okay? We'll talk more about that throughout the chapter. Values of the independent variable are called inputs. Values of the dependent variable are called outputs. So, for example, if I take a bunch of ingredients, flour and eggs and stuff like that, put it into the oven, okay, the ingredients would be the input because I'm putting them into the oven. My output, or what I take out of the oven, would be my cake, okay, after I put all the ingredients together. So, input, what you put in, output, what you take out. You always put the independent variable, you always put that number into the equation, you get the other number out as an answer, for example. I mentioned it in the other lecture. We're going to use tables, words, equations, ordered pairs, graphs, all at the same time to represent some of these relationships. And I said that most of Chapter 4 is just trying to realize how all of those different ways to describe something are related. Here's example 1. Now there's lots of pieces to this problem, so follow along, pay attention. In the diagram below, what is the relationship between the number of triangles and the perimeter of the figure that they form? Remember, perimeter is distance around the outside. It says represent this relationship using a table, words, an equation, and a graph. So lots of stuff that it's asking us for here. Okay. First of all, if we just look at this first triangle, here's one triangle. And the perimeter would be 3, 4, and 3 for a total of 10. If we add another triangle, and we have two triangles, the perimeter, 3 plus 4 is 7, plus 3 is 10, plus 4 more is a total of 14. Remember, perimeter is distance around the outside. I don't care about that line that goes through the middle. If I add another triangle, 3 and 4 is 7, and 4 is 11, and 3 more is 14, and 4 more gives me a total of 18. If I add one more triangle, 3 and 4 is 7, and 4 more is 11, and 3 is 14, and 4 is 18, and 4 gives me a total of 22. So what I'm doing here is I'm adding triangles. I went from one triangle to two triangles to 3 to 4. So I'm changing the number of triangles. The perimeter is changing on its own. So there's two things that this question is asking about. It's asking about the number of triangles and the perimeter. So those are going to be my two variables. Now, which one was I changing? I was changing the number of triangles. Okay? So when it says define the variables, x is going to be equal to something, y is going to be equal to something. Okay? X is your independent variable. X is the thing that you are changing. Okay? And in this problem, I'm changing the number of triangles. What else is changing because of what I did? Well, when I change the number of triangles, perimeter changes on its own. So y is the dependent variable, so y is the perimeter. Okay? Next, it says complete the table. So if I have one triangle, what's my perimeter? Well, I found it up here in my shapes. When I have one triangle, the perimeter is 10. When I had two triangles, the perimeter was 14. Three triangles gives me a perimeter of 18, and four triangles gives me a perimeter of 22. So the first part of the question said, turn this problem into a table. Well, we just did that. Okay, it said complete the table. That's our table. Okay. Next, we're going to have to work on turning this into words. I need more room on the screen. Okay. Example 1 continued. There's two ways to figure out a pattern in words. Okay. Let me fill in the table again here. So we had 10, 14, 18, and 22. The first thing you can try to do is find out how to get from one of the x values to the y value that goes with it. For example, how can I get from a 2 to a 14? Okay. There's several different ways I can use math to get from 2 to 14. I can add 12. Okay. If I do 2 plus 12, that gives me 14. Does that work for this set of numbers? If I do 3 plus 12, does that give me 18? No, it doesn't. So I know that the way what I'm trying to find is what kind of math works for all four of these groups of numbers. What kind of math works for 1 and 10, 2 and 14, 3 and 18, and 4 and 22? Adding 12 works for 2 and 14, but it doesn't work for any of the rest. So I got to find another one. What if I multiply by 2 and I add 10? Well, that works for 2 and 14. 2 times 2 is 4, plus 10 gives me 14. Does it work for 3 and 18? 2 times 3 is 6, 6 plus 10 is 16, and I'm trying to get 18. So I know that that doesn't work, so I have to try a new one. What about times 3 plus 8? That works for 2 and 14. Does it work for 3 and 18? 3 times 3 is 9, plus 8 is 17. Well, I'm closer, but I'm trying to get to 18. So that doesn't work either. What about multiply by 4 and add 6? Okay, it works for 2 and 14. 3 times 4 is 12, plus 6 is 18. Ooh, it works for this one too. Does it work for my other two sets of numbers? 4 times 4 is 16, plus 6 is 22. That works. 1 times 4 is 4, plus 6 is 10. Ooh, it works for that one too. So I found something that works for all four sets of my numbers. It works for all of the rest of my problem. So what I'm going to use here is I'm going to take the number that I started with, which was my x values, and I'm going to multiply it by 4, and then I'm going to add 6. Okay? In words, remember we're trying to describe this pattern in words, multiply x by 4 and add 6. That's what we had right there, and so we just write it out in words. Okay? So you can, like we said, there's two ways to do this. You can try to figure out how to get from one of the x values to one of the y values and find something that works for all of them. Okay, that's one method. There's another method. You can use either one you like. I'm going to fill in my table again. These are the same numbers that we've been using. The other way you can figure out the pattern in words involves two steps. First of all, what's happening to the y value in each step? Okay, remember, these are my x's, these are my y's. What's happening to the y each time? Well, from here to here is plus 4. 14 to 18 is plus 4. 18 to 22 is plus 4. So each time I go up a number, I go up by 4. In this problem, each y value goes up by 4. Okay, that's the first step. Okay. Now, it says what y value would you get if x equals 0? Okay. So if I make my x values go up by 1, from 1 to 2 and 2 to 3, that means that my y values are increasing by 4. Well, what if I wanted to figure out what went with a 0? What number would go in that box? Well, instead of adding 4 as I go to the right, I'm going to subtract 4 to get the one that comes before it. So if I work backwards, 22 to 18, subtract 4. 18 to 14, subtract 4. 14 to 10, subtract 4. 10 to this number, subtract 4 again, and I get 6. So I just use the pattern backwards to figure out what would match up with 0. Right? It says if we work backwards, an x value of 0 gives you a y value of 6. Now, here's what this means. Whatever's happening to the y value each time, this add 4, you're going to multiply by that number. Whatever goes along with x equals 0, you're going to add that number. Okay? So this really gives us 4 is multiplying the x, and 6 is being added to the x. Okay? We end up with the same thing we got on the previous screen. Multiply x by 4, add 6. On this one, multiply x by 4 and add 6. Okay? 2 methods, you get the same answer either way. Still working on example problem 1. So we figured it out in a table. We figured it out in words. Now we need to write an equation. Okay? So if I go back to my words, I'm going to take x, I'm going to multiply it by 4. 4 times x. And then I'm going to add 6. The 6 is being added to the x. Add 6. Now, what am I missing here? I've got, this is supposed to be an equation, so I need an equal sign. What do you think is going to go to the left of that equal sign? Well, I've got an x already. What else do I need in this problem? I need a y. Now I've got an equation. Okay? So I took the words that I figured out on this screen, turned them into an equation. Take your x, multiply it by 4. Take your x, add 6 to it. And that's how I get my equation. The words turn straight into the equation. And I can write the equation here. Y equals 4x plus 6. Now, if you go back to the table for a second that we've been using, okay, here's the table. This one's messy because we wrote all over it. But 1 and 10 went together. 2 and 14, 3 and 18, 4 and 22. I can take each pair in my table and turn it into an ordered pair. Ordered pair, the x always comes first, the y always comes second. I use ordered pairs to graph points. Okay? So I'm going to take my table and turn it into ordered pairs. So I had the ordered pair 110, 214, 318, and 422. Okay, I got those ordered pairs from my table. I can just turn my table into ordered pairs. Now, I have to put those ordered pairs on the graph. So, x comes first, then y. X is on the bottom, y is on the top. So I need to plot the point 110. Here's 110. 10 would be right about there because it's in between 9 and 12. 2 and 14 would be about there, just a little bit less than 15. 3 and 18 would go there. 4 and 22 would go there. Okay? So, I've got a graph. I've got an equation. I've got it written out in words on this screen. I've got it written out in words on this screen. And I also have a table. Okay? If I go back to the original problem, it asked me for a table, which we have. It asked me for words, which we figured out. It asked me for an equation, which we translated. And it asked me for a graph, which we put together using ordered pairs. Okay? Lots of work for a problem like this. Okay? Here's one to try on your own. Okay? Same type of thing, but in this case we've got trapezoids instead of triangles. Still talking about perimeter. Okay? So, make a table. Write out the ordered pairs. It's going to continue on the next screen. Turn the ordered pairs into a graph. Make sure you put numbers on your graph. A graph that doesn't have any numbers doesn't mean anything. Okay? So, you're going to have your y-axis, your x-axis. You need to have labels, and you need to make sure you plot your points. Okay? Make sure you put numbers going up the side and across the bottom. You also need to use words to describe the relationship, and you also need to write an equation. Okay? Lots of stuff that problem asks you for. Next information. A function is a relationship that pairs each input value with exactly one output value. Remember, the input values, those are your x's. The output values, those are your y's. So each x has to have one y that comes with it. Go back to your cake example for a second. If I put flour and butter and eggs and chocolate and all that stuff into the oven, I'm not going to get out a steak dinner. Okay? I can't put one thing into my oven and get two different things out. It doesn't work that way. I can't put one number into my function and get two different answers. That'd be like saying that sometimes 2 plus 2 is 4 and sometimes 2 plus 2 is 5. It doesn't work that way. If I put the same numbers together, I'm going to get the same answer every time. Here's an example of a problem like this. Does each relationship show a function? Remember, for a function, each input value has to have exactly one output value. Okay? So, this input of 1 has an arrow that goes to 2. Okay? That number 1 doesn't go anywhere else. It just goes to 2. The 3 only goes to a 4. The 2 goes to -1. The 5 goes up to a 4. Okay? Now, I have a 4 that shows up in both of these places. That doesn't matter. Okay? The thing that matters is there's only one arrow coming from each one of those numbers. Okay? So this one would be, yes, it is a function. In this one in the middle, the number 1 goes two different places, to 1 and to -1. The number 4 goes two different places, 2 and -2. Okay? I can only have one arrow coming from each input value. Not a function. Because if I put a 1 in, I can get two different answers out. That's not okay. If I put a 4 in, I can get two different answers out. That's not okay. Okay? Not a function. What about this third one? -1 has one arrow coming from it. -2 has one arrow coming from it. 1 has one arrow. 2 has one arrow. Each one of my inputs has one arrow coming off of it. So yes, it is a function. Another definition, a linear function. Linear starts with the word line. A linear function is a function whose graph is a straight, non-vertical line. It cannot be straight up and down. Okay? It can be sideways, it can be diagonal, it cannot be straight up and down. And it cannot curve. It has to be straight and non-vertical. So if they give you a graph and they say, is this a linear function? If it's a straight line that's not straight up and down, it would be linear. If it curves at all, not linear. There's another way that you can tell if a function is linear or not. We talked about it in the last lesson in section 1. You can use a table or ordered pairs to determine if a relationship is linear. Remember in the last section we said that if something is a straight line, the x values will all change by the same amount, and the y values will all change by the same amount. This is saying the same thing. A linear function always has x values that are increasing by the same amount and y values that are increasing by the same amount. I shouldn't have used the word increasing because sometimes they can be decreasing. I could put changes, either up or down. And I can do this one, same thing, changes by the same amount, either up or down. Here's an example of how I do that, example 3a. Is the relationship in the table at the right a linear function? So they give us a table. We need to look at our x's. What's happening to our x's? Plus 1, plus 1, plus 1. Are our x values doing the same thing all the time? Yes. What about our y values? Plus 2, plus 2, plus 2. Are my y values changing by the same amount each time? Yes, they are. If the x values and the y values are always changing by the same amount as you go across, then it is a linear function. Another way you can look at that, example 3b, do these ordered pairs represent a linear function? Well, I can't do the same thing I did up in this table to say that it adds 1 each time or that it adds 2 each time. But I want you to look at something here. When we looked at this screen, this one in the middle, okay, if I turned these inputs and outputs into ordered pairs, so the ordered pair 1, 1, 1, negative 1, 4, 2, and 4, negative 2. Those are ordered pairs. It is not a function if you have 2 of the same x values. I have 2 1s. That doesn't work. It's not a function if you have 2 of the same x values. Those are both 4s. Okay? Now, if we look at the one that they gave us, it's not a linear function if I have 2 of the same x values. Well, look here. I've got x equals 1 in that ordered pair, and I have x equals 1 in that ordered pair. If I have 2 of the same x's, not a linear function. If I have 2 of the same y's, that's okay, but I can't have 2 of the same x's. So, does the set of ordered pairs represent a linear function? No, because I have 2 of the same x values. And I'm not allowed to do that. Practice problem number 2. Graph these ordered pairs. Determine whether the relationship is a linear function. Explain how you know. Remember, when they give you a graph, a linear function is a straight line that doesn't go perfectly up and down. Okay? It can go straight sideways, it can go straight diagonal, can't go up and down. So graph those points, see if you get something that's a straight line or not. Again, blank slide at the end for you to write down any questions that you have. We can go over those at the beginning of class.